Okay, welcome. Thank you all very much for joining my session called Pragmatic Architecture Today. I'd like to start with a very short introduction about myself. My name is Bart Blommaerts. I live and work in Belgium in a company called Ordina. I work there as a hands-on application architect. More specifically in our JWorks business unit. And in JWorks we mainly do Java and JavaScript. If you have any questions for me, or rants, or just want to ask me something, whatever, you can always reach me on my Twitter handle. Now, I have to say, I'm very happy that I'm here, so thank you very much for inviting me. It was actually pretty difficult to get here, because just yesterday I was at Eurodev in Sweden, and I flew to Kiev via Prague, but our flight was delayed for over an hour, so we missed the connection. And the people from Czech Airlines were very, very supportive, so we got to sleep in the airport. It's highly recommendable. And there was this one guy who was also on our flight, who also had to sleep in the airport. He slept in like the kindergarten. So it was really strange when I actually arrived here at the conference to see him. So he's here as well, so we shared the night at the airport. Really great, very recommendable. So that's just if you see somebody like hogging the coffee machine like a zombie, that's me. So don't worry. Let's get started. Architecture. I have a question for you guys. Who here in the room is a software developer? Okay, that's most of you. Another question: who is a senior software developer? So lots of experience, big projects. Yeah, I understand it's amazing. Okay, 2 more questions. Who is a technical lead? So you manage a couple of projects, couple of developers. All right. What will my last question be? Who is an architect? 1 guy, 2 guys, 3 guys. Okay, great. Everybody else can just go. No. No. The thing is, there are so many definitions about architecture. Basically, every company has their own definition of an architecture, and I'd like to start by giving more of an introduction of what I believe is architecture, so that we can start on the same track. Now, I'm not going to present to you another new definition, because I didn't feel like coming up with one. I personally really like the approach by Iwan Woods and Nick Rosansky in their book called Software Systems Architecture. And the cool thing about their approach is that it also copes with the problem that, well, all projects are different, and all projects are likely needing a different kind of architecture. So let's start with like a slow and small introduction. Everything starts with a system. If we are not building a system, well, we're not going to do an architecture either. We're not going to implement anything. Now, when I specifically talk about a system, I talk about all the components that, when combined, make an application. So I'm not talking about a system of systems. That's like more something for enterprise architects, and that's not what I'm going to talk about today. A system is made for a stakeholder, because if there are no stakeholders, well, again, then we're not going to implement a system. Who are these stakeholders? Well, it's basically all of us. It's the developers, it's the users, it's the people who are paying for the project. They're a very important stakeholder, as it appears. So what you need to do as an architect is to share a crystal clear vision with all of these different stakeholders. And every system has an architecture. It's not necessarily that this is like a formal architecture. It can just be like this big ball of mud that exists. But every system has an architecture. And this architecture is typically described in what is called an architectural description. Now, the goal of the architectural description is to help understanding of the system that we're building. And it's to help the stakeholders understand that. So we need the architectural description to make architectural decisions explicit. An architectural description uses views. This is in the model by Woods and Rosansky. Now, these views typically describe what is significant for an application. Now, this is also like kind of a fuzzy topic. What is a significant view? Well, it is significant if your application cannot live without it. Or if some of the stakeholders say, well, we need this information, then it's critical. And there's like also the common saying that when we make decisions to write views, we should try to decide that on the last possible responsible moment. This is an overview of the views from the book Software Systems Architecture. There's the context view, the functional view, information view, concurrency view, I need to look, development view, deployment view, and the operational view. Now, I'm not going to talk about these in depth during this presentation. If you want more info, then feel free to meet me at the speaker booth. But I believe that, well, most of you will have some kind of idea what these views mean, and I also have a couple of examples later. Now, why am I not going to explain these in detail? Because I really believe that you should be looking at their book. I had the opportunity to meet Ewan Woods a couple of weeks ago, or maybe a month ago, at JAX London, and he also says, well, we know it's kind of a difficult book, but we ourselves are still using it every day as a reference. So that's really a nice case if you can have just put the book on your table, and if you have questions, then have a look at the book. Really recommend it. Now, these views, they are shaped by perspectives. These perspectives are typically cross-cutting concerns, so the non-functional requirements, sometimes also referred to as the system or quality properties. So another list of all these perspectives. One that I really care about is the evolution perspective, and I will be talking about the evolution perspective a lot more in just a few minutes. I believe that the evolution perspective really is like a differentiator in an architectural description if you're building that today. Who's still awake? Ah, 3 guys, great. I know I'm the one who's supposed to be sleep deprived. No, I know this is a bit high level, a bit not so very tangible, so let's do something about it. This is a Formula 1 car. It is the Mercedes 2016 Formula 1 car, driven by Nico Rosberg and Lewis Hamilton. It actually won the Constructor Championship this year. It is about 850 horsepower, and it is made out of 80,000 different components. The estimated price of the car, $10 million. And that's just for the car. That's not research and development. That's not moving it to different racetracks. So this is a $10 million car. Now, I would like to talk to you about cars for hours and hours and hours, but well, that's not why we're here today. If we look at the views we had earlier, we can really see this in the car as well. So for example, this car needs to be built somewhere, and as you can imagine, the development view of a Formula 1 racing car, well, it's different from making like a Mercedes truck, obviously. If you look at, if everybody ever saw a Formula 1 pit stop, then you will see that there are a lot of people, the operations people, who are just maintaining the car while it's doing the race. So they're doing DevOps. It's really cool. That's something that you can put in the operational view. And I also mentioned it briefly. This car is transported to racetracks all over the world. It does about 100,000 miles per year, per season. So also there's some kind of deployment view. How will we get the car to the racetrack? Now, what is really cool about this car? Well, it's actually the successor of the 2015 Mercedes race car. And the 2015 car also won last year's championship in Formula 1. And what's strange about the 2015 car? Well, it is actually currently standing in a museum. There's a couple of cars and they're standing in museums. They're not being used anymore. So there's a $10 million car that's not being used today. Who is building $10 million applications? There was one guy who was about to raise his hand. That's really cool. No, but this is a bit like a throw-away approach. I mean, who in the room still uses his first iPhone? Who had the first iPhone? Nobody buys iPhones? Okay. Android devices, smartphones. Who still has his first smartphone? That same guy still has his first smartphone. What we see is this is like throwaway economy. We're not using the older devices that we had in the past or the older cars that we had in the past. So what makes this car different? Why is this car winning the Formula 1 championship for 2 years in a row? It must be its architecture. The research and development that went into building the car. And of course, its ability to change. Because there will always be change. There is expected change and unexpected change. There will be new regulations, there will be competitors, the market is changing, and things like that. So the reason that this car has been successful for 2 seasons is really its ability to change. And if we look at like application architecture, there's a very nice quote by a very famous man, Grady Butch, saying, architecture represents the significant design decisions that shape a system, where significant is measured by cost of change. It is difficult to get a system right. Sometimes it's even impossible to get the system right for the first time. So when we're doing the architectural description, we should try to make decisions that can evolve, that can change. Now this can be handled in a couple of ways. You can have loosely coupled, for example, microservices like everybody else is talking about. Or you can have like this huge meta model where you can configure the actual application. So there are different architectural patterns that can enable this. I like cars a lot. This is the engine of the 2016 car. And now you can imagine that this engine was built by the engineers who really know everything about the engine. It's not the same people who are also doing the aerodynamics of the car, or the tires, or the brakes. I mean, you can have the best brakes, you can have the best tires, you can have the best engine, but if they don't work together, then you're not going to have the best car. So if you're architecting a project, it's also very important to always make sure that the integrity of the system is maintained. How can you do this? Well, I believe that an architect needs to be part of the team. And as you're part of the team, you can like lead the team, but lead them by example, not lead them by direction. That doesn't work. So as an architect, I believe that you should really be present of all the sprints, definitely in the beginning of a project if you're doing agile development. Sometimes many projects going to go like in auto mode, just add a new screen, do CRUD on a different table in the database. At that specific moment, less architectural decisions are necessary, but still, if you're part of the team, you can make sure that you give ownership to the right people. You have the people who are building the engine, that they make sure that it works together with people who are building the brakes. So I believe that as an architect, you should be spending most of the time collaborating with your colleagues. You should not be this ivory tower kind of architect, because I don't believe that that's a very nice way of working in today's agile projects. Now, of course, I had a question about it at the previous conference saying, well, being part of the team and giving ownership to different people, well, basically that means that nobody takes ownership and that nobody is responsible for the architecture of your application. And of course, that's not what we want. So if you have the role of activity or the role of architect in a project, you should still make sure that you maintain responsibility. Now I mentioned the questions. I actually received a couple of t-shirts by the organization. So I will be handing these out to whoever has the best question, preferably about architecture or about Formula 1, that's also cool. And then you can have a very, very cool looking t-shirt. Don't wait until the end. If you have questions, just raise your hand and we'll talk about them. So being part of the team as an architect, you should not be enforcing technical decisions. It should really be about facilitating people, facilitating technical decisions, and collaborating with everybody together. So there should never be, and I repeat it, one godlike architect who decides everything. It's the team who works together. And I believe that this way you will have a successful project. And you should also, as an architect, like embrace the fact that people are going to challenge you. And that's a good thing, because if people are challenging you, that means that they care about what you're doing. They care about it enough to go in a discussion with you. And in the end, everybody just wants to have the successful project. So, being part of the team as an architect will lead to a system with a consistent vision. This is the only way that the system gets implemented the way it was envisioned. I mean, if we have the most perfect architectural description, and then it's being implemented completely different, well, you should not even do the architectural description. If we're part of the team, and this is a question for you guys, should an architect be involved in the code? So who believes that an architect should definitely be involved in the code? It depends. Okay. On what? On size of the project. No, it's true, it's true. But on the other hand, how can you be sure that whatever you have been building as the architectural description gets implemented if you're not looking at the code? Okay, good. Yes, got that one right. There's actually another reason for that as well. I mean, imagine that it's Friday morning, and it's the last week, the last day of your sprints, and there's just one user story that needs to be done to have a successful sprint, to go to like a sprint celebration in the evening. As a developer, you pick it up and you know, I can probably make it if people don't look at what I'm doing. I mean, cutting corners in Agile project, it happens. Is there somebody who has never done that, cutting corners? Oh, you're all very honest. I asked this question a couple of days ago and everyone said, no, never. Cool. Now, I mean, as an architect, you can really take pride in what you're building, but you should take pride in your architecture if it also gets implemented in that way. So just my personal opinion, yes, experience the same pain as everybody else on the team. That doesn't mean that you need to take all of the architectural decisions or the technical decisions. Often when you work as an architect, you might be working on multiple projects at once. And if you're not like the best suited guy to go for a technical decision, then give ownership to your technical lead or to the people who are most experienced with that. And again, they will challenge you, but you should also be challenging them. And that really gets the energy flowing. Now, if you're working on different projects as an architect, chances are that you might not have all the time to be picking up a lot of the user stories. That's possible, but there are still other things that you can do. Most architects have a technical background. They have been writing code, so let's not throw that away. You can use your experience to support the other developers. You should use it to coach them, and in that way they can also grow in their role. You should definitely try to come up with best practices together with the development team. Maybe do code reviews. If you're not sure about something, do a proof of concept. And something that I really recommend, look at the possibilities to build reusable building blocks. Small recap. So, an architecture description, it's going to describe a system. And the system is made for the stakeholders. The developers are very important stakeholders, but of course the customer and the users are equally important. When possible, I really should think that in an agile world you should focus on the evolutionary perspective of the architecture. And I believe that an architect needs to be a member of the team. And in my opinion should be involved in the code. Now, what does this architectural description look like? We'll have a quick sip of water. Now, many people nowadays claim that the only valid architecture is what you can derive from the code. And I don't believe that. And there's another quote, again, by Mr. Grady Booch, who says, "One cannot see the ocean's currents by studying drops of water." And I really, really like that. I think it's very poetic. And I also believe that it's very true. I mean, the code of a project, it's very important because that's what's running on the server or wherever it's running on. But it's not enough. It's not going to be a very clear and good way of explaining the architecture of the system, so of the system itself. So we need a certain kind of visualization, and this visualization has a goal. And as an architect, you should really try to be consistent. Consistent in your architectural decisions and in your architectural description. If possible, if you're doing multiple projects at once, try to be consistent cross projects, because then you will also be getting better at what you're doing. The architectural description can be used for reporting to stakeholders, but it can also be used to validate what you're doing. But most important, it's about sharing information. If you can really put the architecture in the heads of the stakeholders, then I think that they're doing a great job. Some ground rules. Who in the room regularly uses UML? About 15%, I say. Okay, who likes using UML of those 15%? Still a couple of you. Okay, that's good. That's good. I believe that UML is not necessary for for most architectures, but it can be very useful. But then you should really be using UML as a language, because it's a language. So if you want to use your designs, your diagrams, to, for example, generate code for them or generate data from them, then I believe it's very useful. And I've seen this in being very successful, but there's really a reason why code generators have a bad name. So when you're doing this, be conscious about the way that you're doing it. An alternative, if you're not focusing on UML, is just using boxes and lines. And now the risk with doing boxes and lines is that it can become inconsistent fairly quickly. If you're using boxes and lines, try to be consistent. Provide a legend to everything that you're doing, even to the most obvious things. So if you have a box that is going to represent something, just add a legend on the side of your architecture saying, this box means whatever, database. And if you're doing boxes and lines, then you should also make sure that the stakeholders understand, because UML was actually designed by Grady Butch to have a uniform way of communicating these diagrams to each other. And what we see with both technical and non-technical stakeholders is that, well, that's not what UML is doing. Often people have no clue what those boxes mean, and then it's no different from boxes and lines. So feel free to use boxes and lines, add a legend, and just put more text in it if that's useful. I'll give you an example just later. Some more ground rules. Always, that's 3 times, keep a decision log. I believe that the decision log is really very important in every architectural description, because it will be documenting your decisions. And since we know that systems always be changing, it's really nice if you can come back to, well, why did we take this decision? Why did we go with a NoSQL database? There will be alternatives, and if you can also describe the alternatives, then you know that you took a conscious decision. And if necessary, you can revise it. I mean, change is happening all the time. This also is more about boxes and lines, but it goes for UML as well. Try to avoid fluffy diagrams. If you're not 100% sure of what you're designing, then believe me, the development team or the stakeholders or the end user, they're also going to be very confused. So try to be very clear about what you're designing. Try to avoid mixed abstractions, and that's very difficult. I find that very difficult as well. You should really be focusing, okay, this is, for example, my information view. What I'm going to put in this information view is about the data, about the database, about data structures. It has nothing to do with the functional view. I mean, a table in the database, it has a functional use, really, I fully agree. It's not for the information view. And also, only document what's useful. If you don't have a database, then don't create an information view. Or if you're not using data stores or anything, then just don't make these. Why? Why do we need architecture? Any answers to that question? Why do we need it? Do we need it? Yes, we need it. Okay, I see some guys nodding, that's good. I believe that, like the previous slides, already have given some answer to that, but I would like to dive in a bit more. When you're doing upfront design, it gives you a really nice moment, an opportunity to think about the bigger picture of the system that you're designing. For example, the technology that you're going to use. We all benefit from automation nowadays, so in that inception phase, you can also be looking at, okay, what are we going to automate? Are we going to run Docker containers? Who is going to manually, who is going to make these Docker containers? Will it be like some kind of developer doing it manually? You should not do that. So that's really nice way, a moment of working on that. Also, the patterns that I was talking about earlier. There are different architectural patterns, like for example monolithic applications, distributed applications, etc. It's very important that as a developer, as an architect, you know what these are, but you also should know that these will evolve. So architectural patterns, they evolve. Distributed patterns were like really not done 5 years ago, and nowadays everybody thinks, okay, we should be doing microservices, so it evolves. You should also be thinking about the layering. Are we going to use a typical n-tiered application, or are we going to use more like vertical slices, maybe do DDD? That's like a very nice moment to talk about that. Again, evolution. Think about the evolution of the application that you're doing. And always be pragmatic. When doing upfront design, it should be fairly small. So that the developers can actually start building the system. And since you're the architect and you're in the team, you can keep on working on the architectural description. There is a very famous quote by Simon Brown saying, just enough upfront design to create the firm foundations for the software product and its delivery. This is a famous quote. And when I first showed this, I got the question, yeah, but what does this mean, just enough? Well, just enough depends on a lot of things. It depends on the budget of what you're doing, on the size of the project, on the team, on all those different things. But I believe that one of the main key differentiators from the very beginning is just the type of project. For example, is this a greenfield project? Can you start from scratch and go wild? Or is there an existing code base? I would like to focus on these two. Imagine that you have the opportunity to do a greenfield project. What I believe is that one of your first diagrams in the upfront design should be something like a component view. Now, component is a very scary word because a lot of people understand different things if you mention component. There was a quote on Twitter for a couple of days ago by one of the Lightband guys saying, well, I don't like the word component because everybody thinks something else. I would like to call it thingy. Okay, so you make a thingy design diagram. That doesn't matter because you will be providing a legend for it, and it will be clear and concise and only have one goal. Now, the components of the system, it should be high level, but it's a working document, so you can add details later. This is actually an existing use case about an IoT application. So in this design we see, does this work? There's data, and the data is coming from IoT sensors. We don't know how it comes to us, but they told us that it will be coming. So we say, okay, there's data, and we're going to pass this data to something that is going to read the data, maybe do some parsing. And we know that it's going to be a lot of data, because in general IoT, well, there's often a lot of data, and we're going to publish it on a queue. We have no clue what this queue is going to be at right now. But since we're putting stuff on a queue, to have really asynchronously built in, we're going to also have something that's going to be subscribed to the queue so that it can consume every message that we're putting on the queue. And this component will then persist it to a database. This might be a relational database, it might be NoSQL database, no clue. And finally, there will be a service that will be reading from that database to provide actual functionality to the end user. Now, this is very high level, but once the project gets going, for example, when you see this, you can already start doing structure in Maven or in Gradle, because you know, okay, there will be these different components. You can start investigating what's the best queue for our use cases, and that's where you also can collaborate with the team. I mean, what queues do we have experience with, for example? And you should be updating this while decisions are being made. Now, if you have an existing system, it's a bit different, because you will need to do some kind of mapping of the as-is situation. You can be very lucky and see, okay, this architecture from this application, it's very nice. We're going to have a very nice initial as-is situation, or it can be really bad. I've seen both, and both present their challenges. But when we have the as-is situation, we can go one step further and look, okay, why are we working on the system today? What is our domain of change? What's the customer paying for? Because if he's not paying for anything, then well, we just leave it at this. If we have this domain of change, I would really recommend to look at the existing code base for extension points, because we were talking about evolution in a couple of previous slides. If we have an as-is situation, and we know what we're going to be putting in the domain of change, then these extension points become very valuable, because those might be the places where we're going to put the new functionality. Another reason why I believe that architecture is very important is for communication. During the inception of the project, so when it's not really has taken off yet, you will be talking to a lot of stakeholders. And when you're talking to stakeholders, you're going to see that they have many desires. They want a lot of things for the application. And in general, all stakeholders preferably want something else. So you're going to be needing to make this. You're going to make decisions with these stakeholders. So if you can involve them in the decision-making process, chances are that you have more luck making the correct decisions. But aligning the requirements from the different stakeholders, that's always a challenge. That's not changing. And here, clear communication with nice diagrams can be very useful. Since I believe that the architect should be part of the team, he will also be present during the development process. And during the development process, it's about sharing a technical vision. Everybody in the team has the same goal: make the application, make the system. And if everybody in the team knows, okay, but this is how we're going to do it, that's key. Then you will be very efficient, I believe. And last but not least, politics. Who has here worked for like large governmental or banking kind of projects? there's a lot of politics involved in these. Because you will see that some stakeholders, well, they will question your decisions. They will always believe that their option was better. But it's very difficult to cope with this. So as an architect, you should really continue looking at the bigger picture and really be conscious why you're taking a decision, and also make sure, well, my decision, it can change. Another political aspect of the role is the fear of change at corporate IT. I believe that probably everybody already has seen systems, well, let's not touch it because it will probably explode. In the famous The Phoenix project, there was Brent, and Brent could touch the system, but the other 40 guys, they should just look at the system. This is just something that you can facilitate if you have a nice architecture and people can understand what the system is doing. Okay, so we have established what the architecture should look like, why we need it, but how are we going to make an architecture, an architectural description? For example, how do we write a good context view? And for this, I would like to introduce John Boyd. John Boyd is a United States Air Force fighter pilot. This is actually not his plane because he lived like in the 60s or the 70s. Well, then he did most of his work, but I just thought this was a cooler plane. And John Boyd came up with a system that is called OODA. It stands for Observe, Orient, Decide, and Act. Now, if you're know a thing or two about these things, it's kind of related to PDCA, which stands for Plan, Decide, Check, and Act. But in Agile projects, I believe that OODA makes more sense, but don't worry about it. I have more slides about this. Now, in the world that we live in today, we will need to observe all the circumstances that are surrounding our system. For example, the external applications where we need to interact with. Also the internal within our customer or within our project things that we need to interact with. And we're going to try to understand what we are observing. When we can do that, we can also decide on a response. Okay, we have made these observations. It means that we need to do something. What are we going to do? When we have finally decided that, then we can do it. Now, as you can see, this is not necessarily a linear process. There are feedback loops introduced in every step. So it is very possible and likely that when you make a certain decision, that this will have an impact on an already existing view, because it will be something new that you can observe. And the system is also re-entrant, and I will have a nice example from that just later on. Now, since the model, the OODA, loops are a re-entrant, we should also not be spending too much time. You should use this like as a mental model, maybe do some sketches on a white paper or something, just saying, okay, what we're observing, but this should not be something very formal, because then it will be very time consuming. So as a summary, before I go to an example, observation means collecting current information from as many sources as possible, from stakeholders, from existing systems, from the enterprise that you're working for. There will also be the orientation phase, where we're going to analyze all of this information. And we're going to analyze this information using our own experiences and perceptions. This is very important. The decision-making process is, well, more clear. We're going to determine a course of action, and we're going to, of course, take that action. Since this might be a bit high level, I have an example. Imagine that we have a very classical application. We have a system frontend, for example, written in JavaScript, a backend that's written in Java, and it consumes some kind of data from a database. System works great, and one day the customer comes over to us and he says, well, there is this external service, and we would like to use it. So when the user enters some data in the user interface, I want you to contact that server. And I'm specifically not calling certain words. I want you to go to that service. So somehow we should go to that service. So what are we going to do? We're going to make observations. We're going to observe the current system, our JavaScript frontend, and we're going to observe the external system. So imagine that we find out that the external system uses JSON over HTTP, and we think, well, JSON, JavaScript, perfect match, right? Might be a naive example, but just imagine, okay, user enters something on the screen, just send some data over the wire to the external system. We decide that we're going to do this. We act, we do the implementation, and the system goes to production, and the customer, he is so happy. He loves it. In fact, he loves it so much that the next day he comes over to you and says, "Oh, this is really cool. Can we also do this with all the data from the database?" Oops. Okay. We're going to make new observations. And one of the observations that we did, well, the system front end does not, it only works for user input. It does not work with what's already in the database, so we're going to need to change something. But now we know that there will be multiple actors in this phase. It will be data from the database, and it will be data for the user. So okay, we decide we're going to implement an external system caller that can send and receive data from the external service. And if we want, in the next phase, maybe we can also make sure that the front end calls that directly. Don't do that. Now, why is this system reentrant? Imagine that we have made the decision to call the external service via the JavaScript frontend, and but we haven't implemented it yet. It's for the next sprint. It will start in a couple of days. And the customer walks over to us and he says, "Well, if you're doing that, would it maybe also be possible to use some of the data that's already in the database? And then you can change your decision without the acting part being done and create something new." Is this more or less clear? Great. Have a quick sip of water. Okay. So if we're going to make decisions based on our observations, it's very useful if we can have better observations. So it might be interesting to look at, for example, the system composition of a running system. So while the system is running, what can we derive from the system? For example, if we have cloud native applications, so applications that using microservices, it would be useful if we have some kind of dashboard that tells us this information about the running microservices, about their state. Is everything working great? Do we have multiple instances of certain microservices? Because just runtime observations can be very useful. A couple of colleagues of mine actually made the microservices dashboards. So if you'd like to know more about that, just come talk to me after my talk. Now, another thing that's very important about runtime observations is measuring value. I think most of you might know the story about Amazon. At the bookstore, at a certain moment in time, they added a button on the right-hand side of their page, and the button didn't do anything. It was just an empty button. But they were keeping track of how many users were clicking that button. So they had no functionality, but they could see, okay, what do we need to do to make sure that people, that our users see that button? Change the color of it, make it bigger, make it smaller, and things like that. Those are runtime observations that you can get from the system. And just putting an empty button on the screen and logging some information, that's something that you can do very quickly. These observations, most of the time, will be application driven, so meaning that you will need to do some kind of implementation for them. But it's all about capturing data from your running application. What's the drawback of this? The more data that you capture, well, the more data that you will have to observe, and you will need to analyze this as well. So keep in mind, if you're using this, that there will be some orienting work as well. Okay, that was actually my last slide. I have a couple of books and links that I think that are very useful to read. Definitely have a look at them. Especially the Software Systems Architecture by Rosansky and Woods. I really recommend it. Again, it's not the most easy book. It's not the easiest book to read. It's fairly large, fairly lot of text, but you can also use this really as a reference. It's on my desk, and I look at it often. And a couple of other interesting things.